everyone, welcome back. Okay, now that we've established what the conditions or requirements are for the existence of neutralizing processes, neutralizing phonological processes in a language are, we can consider a method for actually discovering these processes, something that can help us when we're trying to conduct a phonological analysis. So our first step will be to look for any allophonic processes, just as we've always done. And there, in particular, we'll want to try to find whether there are contextually limited contrasts. So for instance, of the types that we've already seen, no distinction in nasals preceding consonants, no distinction in voice, obstruents at the end of words, and so on. After that, we will want to carry out a provisional morphological analysis of the data. So by provisional here, I mean an analysis that a first step in the analysis, what we assume the morphological structure is. And there we try to divide up the roots or the stems from any derivational or inflectional morphemes. And here we'll keep in mind that because of the phonological processes, later we might have to return and alter the morphological analysis that we initially made. Once we've collected all of the allomorphs of roots, stems, and affixes and listed those, then we can find exactly which segments are subject to alternation. So in the Japanese data, we see that the segments ma and n are subject to alternation. In the Russian data, if we go back here, we would find that segments like za and sa, ga and ka, da and ta, ba and pa are subject to alternation. So those are things that we would list. At that point, we can make a hypothesis about what the underlying representation for the morphemes that exhibit allomorphy would be. And here, it may be necessary to apply multiple hypotheses. And this procedure I like to call the two hypothesis method. So if we find that segment A alternates with segment B, so in the Japanese case, we can say we have an alternation between segments ma and n, and let's call them segment A and segment B. We can make two different hypotheses. We can consider deriving segment B from segment A or A from segment B. And you'll then want to test corresponding combinations of underlying representations and rules using phonological derivations. So this is where phonological derivations, which we've been using from the beginning, start to seem really more useful because they help to make explicit, to make entirely clear what the predictions of a particular hypothesis will be. Next then, you'll want to posit the underlying representations by putting together underlying forms following the rules of the morphology. And finally, you'll write the necessary rules and their environments of application. And in those cases, if you need to, you can sort the environments of the allophones using the method of local environments to describe a pattern of allophony or a pattern of allomorphy. So that is something that we could have done in the English case here. One could have started in part by applying the method of local environments to see where exactly does za occur, where exactly does sa occur, and where exactly does z occur. Okay, so let's now, I'd like now to illustrate this technique using some other data from North American English. And here we're going to use it to account for the neutralization of some alveolar stops. So now to North American English. And our interest concerns the alveolar stops, the voiceless stop ta, and the voiced stop da, which are neutralized in some environments. And in particular, if you think about the orthography, the writing system of English, there are lots of words which are spelled with the t sign, but in North American English, these are pronounced with a tap. So we would say data, throttle, butter, ditty, notify in all of these words, not a stop. And similarly, there are words that are spelled with the orthographic symbol duh, which if it were used at the beginning of a word like daddy or ditty, it's clearly pronounced as a voiced alveolar stop. But again, in these words, we instead have a stop. So the name Ida, the verb idle or adjective, rudder, daddy, edify. In daddy, it's the stop in the middle of the word, which is tapped. On the other hand, as I've just said, we do find the stop occurring in the language. So words like detain, there we have a stop, to, detain, the place name sautel, the verb deter, petition, rotisserie, and with the stop, the voice stop duh, we find reduce, Adele, predict, reduction, and idolatry, for instance. The alternation, the fact that we find, so this in principle is not something you would want to do, but we can use the orthography of English as a bit of a shortcut here to say that places where the native speakers use a t sign, that probably corresponds to the underlying representation of that sound. So what we can see then is that, and what we'll assume here is that there are phonemes, there are alveolar stop phonemes, ta and da, in English, and clearly the stop is one of the possible allophones. But both, it seems to be the case that both stops have this tap as a possible allophone. I'll take over the rule in 27 from Hayes' textbook for accounting where this tapping process occurs. So if we have a coronal segment, which is a stop, it becomes a voiced tap. So all of these features change. It becomes plus sonorant, plus continuant, plus delayed release, plus tap, and plus voice. If it follows a vowel, so we can see in all of the forms in 25 that the tap immediately follows a vowel, and that it precedes another vowel, which is unstressed. So we'll probably encounter this process at some other points in the course, and we may need to adjust it a little bit, but this rule will work for the data that we are looking at today. Now, this rule of tapping could be based on a purely static generalization. We find the tap occurring in a complementary distribution with the stops ta and da, which are contrastive. So do I have a good example of some contrastive instances? Yeah, we could have picked better examples, but we'll take it for granted that the two stops are contrastive with one another. But what's more interesting is when we find data, dynamic data, in which we find that tapping can lead to alternations between, within verbal paradigms or within other derived forms built to the same verb or adjective. So let's look at some data in 28 where we find alternations in the form of the consonant at the right edge of an adjective or a verb. I'm going to close my window briefly. Yes, back to the data in 28. We find alternations in the form of a verb or adjective based on tapping. So in English, there are two suffixes pronounced as in rhotic dialects, like North American English dialects of English. So if we make a noun, writer, from the verb write, or to an adjective, we make the comparative form wetter from the adjective wet. We get a tap there. And in the gerund forms, the present participle forms, so for instance, writing, built to this same verb, we find a stop there too, preceding the ing suffix. And in adjectives, in the superlative form, built with the suffix ust, so for instance, whitest, wettest, saddest, we find a tap there too. So by following the method which I just laid out at the beginning of 3.2, we've already essentially discovered tapping using allophonic analysis. We find that the tap and the stop are in complementary distribution, and the rule in 27 explains where the tap occurs. When we conduct some morphological analysis of the data in 28, that leads us to posit 4 suffixes. So we have a suffix so I'll list the suffixes over here as well. We have suffix excuse me, for agent nouns like writer or batter or shooter. For comparative forms of adjectives like whiter, or sadder. We have a suffix ust for superlatives and ing for gerunds, present participles. And what we find for all of the adjectives and verbs listed here is that they have 2 allomorphs. So there's one with the stop, ta or da, at the right edge of the stem, and another one with a tap, ra, at the right edge of the stem immediately preceding the suffix. So when we segment, when we segment the word writing, we have a morpheme boundary here, so at the right edge of the stem there. So we can express these alternations as follows. We have an alternation between write and ride, between ride and ride. So the segments ta and da and ra, we can say, are subject to an alternation. The voiceless alveolar stop ta alternates with the tap ra, and also the voiced alveolar stop da alternates with the tap ra. Now we can actually explicitly apply the 2 hypothesis method in this case. We'll use the verbs write and ride as our examples here. So first, let's consider what the 2 hypotheses could be that could be used for accounting for this set of data where we find this pattern of stem allomorphy. So this is what I would call a pattern of stem allomorphy. Hypothesis A assumes that the underlying representations of these verbs have stops. So the underlying representations would be write and ride, and that the allomorph ride with a tap is generated through a process of tapping, which it would seem we can discover for English based purely upon static distributions in the data. The second hypothesis, hypothesis B, would be that, both verbs have the same phonological underlying representation with a tap, ride, and that the allomorph of write, for instance, could be generated by a process of tap hardening, let's say at the end of a word. But as soon as we start to work out, to create this hypothesis, we can wonder, well, how then are we going to generate the allomorph ride with a voiced alveolar stop? Let's first try to consider what happens under hypothesis B. So under hypothesis B, for both the simple present tense form of the verb, like I write or I ride, we would have a tap underlyingly, and preceding a suffix form like the present participle or gerund with the suffix ing, the tap stands before a vowel. So if we can take hypothesis B with this rule of tap hardening, which states that an underlying tap becomes a voiceless alveolar stop at the right edge of a word, in the suffix forms, nothing happens. So the forms writing occur in both cases. That's precisely what we want. That's good. Tap hardening makes the correct prediction for the verb write, because in simple present tense forms like I write, they write, we find a stop at the end of the word. But this would make an incorrect prediction for the verb ride, because we would need to have a voiced stop there, not a voiceless stop. So it would seem here that hypothesis B incorrectly predicts that the verb ride in English should be realized with a voiceless alveolar stop when it isn't followed by a suffix beginning with a vowel. So once we see that hypothesis B clearly cannot correctly generate the data, we can consider that hypothesis A is very likely correct. And it's using the tapping rule, we can then demonstrate that it is correct. So here there is an underlying contrast between the stops, in voicing. So we have write and ride. When the suffix ing is added to form the present participle, then those alveolar stops, according to the rule, these coronal stops, now are not only following a vowel, but they are standing before a stressless vowel. So they are in the context in which tapping can apply, and the underlying alveolar stop becomes a tap, and thus we generate the forms writing and writing. So we see in this context that the underlying distinction between a voiced alveolar stop da and a voiceless alveolar stop ta is neutralized. We may even want to consider another definition of neutralization. And there we could say that it would be the conversion of distinct underlying or phonemic forms into identical surface or phonetic forms. So the morphemes ride and write, which in North American English are underlyingly identical, become phonetically indistinguishable from one another when they are placed in this context where a vowel initial suffix follows them. So this definition just offered under point 4, that presupposes the definition of neutralization that we've already given above. If it weren't the case that the stops ta and da could both be realized as a tap on the surface, then it would be impossible to derive cases where the two forms that have different underlying representations appear as identical on the surface. Now, one last remark I'll make here, which we'll talk about further in the lecture next week, is that one other way to try to analyze this data would be to assume that the morphologically simple form, the form in isolation, so the form occurring in the leftmost column in this case, is equivalent to the underlying representation, and then we would write phonological rules to account for the other more morphologically complex forms. That constitutes a sort of shortcut, Kurzweg, but such shortcuts are not always going to be reliable, and in fact very often will lead to incorrect conclusions. Let's take a brief pause here, and when we return, we'll talk about the psychological reality of such neutralizing processes.